Okay, I'm going to be testing two of Turnigy's batteries to compare them. Now these Turnigy batteries are the existing one is the Ultimate, which comes in this box like this. The Ultimate 6.6. I'll get it out in a minute and show you what's in the box. And compare it to their new Graphene one, which comes in this much bigger presentation box. It's also a 6.6 or 6,600 milliamp. So the box is a lot bigger, and the cost in the UK, this one costs about £15 more than this one. So it's quite a increase in cost. So are you getting more for your money, or is it going to be better? Now, the use of this word graphene is odd, because graphene is a modern material that has been developed, and as far as I know, there's no application yet because it's so difficult to use, but they've called it graphene. Now, graphene is a carbon, and it's similar or the same as graphite, or what you can find in a pencil. Now, how can they use graphene in a battery? Well, there's a lot of blurb on their website about their batteries and graphene, and they talk about, if you look up their spec, of using a single layer of graphene 0.335 nanometers thick. It's written on their website. And it makes the type of battery substrate the thinnest known to mankind. Well, you might not know this, but I'll tell you, 0.335 nanometers is actually the minimum thickness of a graphene sheet, and it is actually 1 atom thick of graphite. 2 atoms thick, 0.335. Now, 1 carbon atom is 0.14 nanometers in diameter. You can't have 1 atom in a sheet. You have to have them in a lattice work, which makes them about twice the thickness of 1 atom, 0.335. Now, how thick is 2 atoms of carbon? Well, this is a 2B pencil. And if you draw a line on here like that with the 2B pencil, now that line, the thickness of the graphite that I've just drawn on there is 20 nanometers thick. I got this from a scientific paper where they measured it. Now 20 nanometers is 143 atoms thick. So that the thickness of that line is 143 atoms. But they're saying that they've got a sheet or a layer on in their batteries which is 2 atoms thick. That's 143. So how thin is that, and how can it be manufactured into a battery? I don't know. By the way, if you want to know what a nanometer is, a nanometer is 1/1000th of a meter. So anyway, that's their claim. They say they use 2 atoms thick in making their batteries. Now on this sheet, you've got their Ultimate and their graphene batteries. And they put a lot of blurb in there, but the important things between these two batteries is they're both 90C, they're both 6,600 milliamps, they're both the same size, hard case. This is a 2S one we're testing, 7.4 nominal, and I'm going to weigh them in a minute, see what the difference in the weight is. There's an awful lot of scientific gobbledygook written on their sites, if you want to go on there and read it. But one of the things they write here is that the construction of the battery creates the ability for imbibition in the carrier liquid. Well, imbibition is not a word, it's difficult to spell, let alone it's not the sort of word that you will use very often. Imbibition. Well, it means to imbibe, which means to take in or absorb. Why they have to use that word, I very much doubt if many people recognize that word. They talk about improving electronic conductivity and ion transmission, reduced impedance, and that's on the ultimate. On the graphene one, they have almost the same sort of words used again. There's a single layer of graphene, and it says forms a highly dense compound. Well, graphene is not dense at all. It's the opposite of dense. It's the thinnest compound known to man. So I don't know how it went from thin to highly dense. Maybe it means that the atoms are next to each other or something, I don't know. Less resistance compared to traditional LiPo battery. Well, over here they were talking about the ultra strong electron conductivity. So both of them have got similar terms. Anyway, here it says that the internal resistance as low as 1.2 milliohms for the graphene, and on the ultimate it says the internal resistance can reach as low as 1.2 milliohms. So they seem to be making the same claims for both. The only difference I can find is here. It says on the graphene, longer life cycle, 600 plus. I don't know anyone who has ever charged a battery that many times. Some battery LiPos do lose their performance over time. I've had some that don't lose any performance over time. So if you want to use a graphene battery for years and years, it looks like it might be just as good at the end as at the beginning. Whereas on the ultimate it says longer cycle life, almost double that of a standard LiPo. Well, we don't know what the cycle life of a standard LiPo is, but they say this is 600 plus, so that's the only difference I can find. Otherwise you would think you were reading about the same battery, except for the ludicrous claims about the graphene. So that's all the technical stuff, scientific stuff. I've made a chart where I'm going to write down the results. I've got the resistance meter and over there, and this discharge meter I'm going to use, and I'm going to take these apart and show you what's inside. Okay, we're going to open them up now, see what's inside, starting with the Ultimate 6.6. But just before we do, I just noticed another couple of weird things on the on their specifications. On the Ultimate it says here, don't get caught with a saggy pack at the track. And on this side it goes, the graphene batteries go harder for longer. So if you don't want a saggy pack or sack and want to go longer and harder, the graphene's going to be the ones for you. Anyway, let's see what's inside. Smaller case, nicely presented. Oops. You got it wrapped up, and in this, and you got the pack here. Interestingly, it's got this hazard tape wrapped around it, and it says read the manual. I suppose that's useful. And otherwise it's a nice case. They still put this sticker on the top, which means it probably gets ripped off by your tape. The ones where they wrap it around the side, I think, is a much better idea. You've got a lead here, which you can. They're 5mm connectors, and a lead, a balanced lead with blank ends on the end if you want to make up a short. Though I find them much too short as charge leads. And nicely, they give you these 5mm to 4mm adapters, which is nice. And this warning label is bound to be all about charge, handling, etc. Now that's that one. We'll weigh that in a second when I get the scales. And look at this, the one for the graphene. As I said, it costs a lot more. I don't know how much money that you're paying has gone into the box. It comes with this kind of a strap round it. I suppose that comes off to hold it, and all in nice black matte sticker here. Same warning thing. And look at this. There's it's in this velveteen pouch, which would be like a nice sack for your saggy pack, if you get one. Again, inside here you've got the same charge lead and the same 5 to 4 adapters. All the rest is just padding. And the battery itself says Graphene 5, and it's got like a shrink wrap around it. I don't know why you've got to rip that off. Maybe it's to show that it's new and no one's had a go at it. Anyway, I'm going to have to rip that off. So let's just weigh them, shall we? Got the 2 packs. As you can see, they are same size. I'll just get the scales. There you go. Turn the scales on. Should we zoom in a bit for you? It takes ages to zoom, doesn't it? Anyway, let's put the Ultimate 6.6 on. Was that on 0? Let's just, yeah, 0. Weighs 304 grams. And now the graphene, 307 grams. So really, it's within tolerance. It's grown in weight. It's 308 now. 305 these scales, but at least so 305, 308. That's pretty close, considering that using different manufacturing techniques. Could be the same battery inside. We're going to find out. Anyway, I'll just charge them up. I'm going to cycle them once before I do a test, because they're from the factory, so it's best I'll do a cycle first, and then I'll do 100% discharge and measure all the voltages. Just testing the IR with this other meter, see if it's the same. This is set to 20 milliohm scale. The ultimate one, let's just get the connections on. On this one it reads pretty low, 1.25 milliohms on the ultimate, and on the graphene one it's reading 2.02. Okay, testing the ultimate 6.6. Just come off charge, fully charged. It's nominal ambient temperature 20 degrees C, and I'm going to record all the results on here when I put it on discharge, and I'll probably edit this down so you don't have to watch it all the way through, because it takes about 6 or 7 minutes to discharge it. And then after I've done this one, I've got the graphene one, which I'll also test and compare. So here we go. I've got a stopwatch. You can see the time as well elapsed. So let's just get the first reading, put that on. That's this and this. 789, and it's dropped to 783, so we put it on here. It's 20 degrees centigrade start temperature, and then I'm going to measure it and record all the results on the chart. Whoops, let's start this off. and then I'll edit it down. I'll give you a slightly better view. You can get that to zoom in. So it's coming up to 600 milliamps, and that's on a Blinky and a few others. It's about 3 laps. So it's 7.70 volts. Then I'll do it at 1, 2, 3, 4, 5, 6 and to the end ampere hours. You're coming up to 1 ampere hour, which would be about halfway through a 5-minute race with a 17.5 Blinky, 7.57. Okay, coming up to 2 ampere hours. So about the end of a Blinky race, 7.44. Okay, coming up to 3 ampere hours, it'd probably be the end of a 13.5 boosted race. 7.31. Small raise in temperature on the you can't see that, on the Lipo, 27 degrees centigrade. Okay, coming up to 4 ampere hours. That's actually dropped about 7.19. I'll put in 7.19. Temperature wise, about 40 degrees. You can just see that. 39 to 40 degrees on the battery. By the way, this discharge unit gets very hot, but the air is blowing away from the battery, not onto it, so it's not heating the battery up. So coming up to 5 ampere hours, that'll be well past the end of a modified race. And up to 6 ampere hours, getting near the end of the capacity of the battery now. .05. Temperature is about 43 degrees, 42, 43 degrees. And then we just see what the maximum capacity is when the voltage drops to 6 volts. It's been discharging for about 11 minutes now. Still drawing 30 amps about. So it's a 6.6 ampere hour battery, so we'd hope it gets to 6.6, which it's going to. Just begin the 4. We grab it when it goes to 6. So it's 6,800. 6,800. There, 6,850. Oh, I'll just write that down. 6,008.5 ampere hour. Temperature is about 46 degrees. It'll go up slightly probably as the heat comes out of the battery. So 46 degrees. We'll stop that at it was about 13 minutes. So I've written all that down, and we'll test the graphene one next and see how they compare. Okay, testing the graphene now. Going to connect it up and write down the voltages. Okay, let's start the stopwatch this time. By the way, nominal 20. Oops. Nominal 20 degrees C on the battery, near enough. Start the stopwatch, plug it in, press that, 789 to 783, 7.70. I'll keep measuring it, and I'll edit this down so you don't have to watch it all the way through. Right, 6 ampere hours, we got 7.05. The temperature of the battery is it says 35 degrees C with this one. Oops. 36 degrees with that one, so I'm going to write that. This other one measures is measuring 45 degrees C. I don't think that's very one of them's not accurate. But the temperature is about as the same as what it was basically measured on the previous one. 689 there, 6.9. 6.9. Stop the stopwatch there. So these 7 degrees, which is what we measured with last time. So basically it's the same temperature as what it was before. I'll take that off. So looking at the results, this is the important bit. Got the Turnigy and the graphene. They were put on charged and put on exactly the same point, and everything's the same. The Turnigy costs more than the Ultimate. The graphene one costs more. So we started off, the two voltages are the same. They start off at 7.83. At 600 milliamps are the same voltage, 7.7. At 1 ampere hour, 757. Actually, this 7.63, it did drop to 7.57 just a few seconds after I wrote it down. So I'd say that was the same. 744, 743, still the same. 731 at 3 ampere hours, same. 4 ampere hours, 7.19, 718, I'd say the same. And then right at the end, the graphene drops off a fraction at 5 ampere hours, same at 6 ampere hours. The capacity 6.86 the same, temperature's the same, time the same. So what's the conclusion? Well, I would say it's the same battery, exactly the same battery. I can't see how it can be any different. The only difference was the internal resistance measurement on my meters, 2 meters I use. One was 1.7 milliamps, the other 1.76 milliamps was close enough. Slightly difference on the other one. I'll check it again in a minute, but the weight is almost the same. I don't know what's going on. The only thing they say about the graphene is that you can charge it up to 600 times. Well, I can't do the test like that and find out. So considering the graphene costs more than the Ultimate, I can't see any point in buying a graphene battery and paying the extra money unless someone else can give me some more information. Anyway, next test, I'll test the 7.5 and compare it to another maker's 7.5 and keep adding to these figures.